Welcome to the video on how to write your lab report for Experiment 3, Introduction to Weighing and Density Measurements. In Part A of the experiment, the technique of weighing by tearing will be demonstrated. In Part B of the experiment, the density of the three liquid samples will be determined using the weighing by tearing technique. To weigh out a sample, the weight of the container should be measured first. Then the sample is added to the container, and the weight of the container and sample is measured. Taking this final weight and subtracting off the weight of the container will give the weight of the sample in the container. Note that this method involves recording two numbers and a subtraction. Each of these steps is a potential source of error. Weighing by tearing is used when the weight of the container is not important. To do this, the container is placed on the balance. After the balance reading has stabilized, the tear button is pushed. This sets the balance reading to 0. Note that the weight of the container does not have to be recorded. The container may be removed from the balance before the sample is added to the container. When both the container and sample are placed on the balance will directly display the weight of the sample. In this method, only one number has to be recorded and the subtraction is automatically done. Therefore, this method has fewer chances for error. Note that one has to ensure that after the balance has been taired, it is not re-taired, i.e., no one else can use the balance during this time. Also note that this technique does not reduce errors due to factors such as sample contamination or spillage of the sample. It may be useful to review the weighing by tearing video. The steps involved in determining the density of a liquid sample will be demonstrated with example data for ethanol. The balance is turned on and the display should read 0.0000 grams. The empty flask with the stopper will be placed on the balance. After the reading has stabilized, the tear button is pushed. The balance reading should read 0.0000 grams. This weight is the balance display of the taired empty flask and stopper that corresponds to the 0.0000 grams that has already been recorded on the data sheet. A known volume of ethanol is to be placed in the flask. To do this, a 10 milliliter graduated cylinder is first filled to a little less than 10 milliliters. The volume of ethanol in the graduated cylinder is read and recorded on the data sheet. In this example, the volume is 9.84 milliliters. Remember to record all the data to the proper number of significant figures. Next, most of the ethanol is poured from the graduated cylinder into the flask. Make sure enough ethanol is left in the graduated cylinder so the volume left in the cylinder can be accurately read. For the final volume to be accurately read, the meniscus must be above the lowest marking on the graduated cylinder's scale. Read and record this final volume. In this example, the final volume is 1.22 milliliters. Place the flask containing the ethanol with the stopper back onto the balance. Read and record the balance reading. In this example, the weight is 6.9046 grams. Note that since the balance was taired with the flask and stopper, the reading directly displays the weight of the ethanol in the flask. This gives all the raw data needed to calculate the density of ethanol. The density of a substance is its weight divided by its volume. In this example, the weight of ethanol in the flask is determined by subtracting the balance reading of the ethanol-containing flask and stopper minus the balance reading of the empty flask and stopper. Note that since the balance was taired with the empty flask and stopper, the weight of ethanol in the flask is equal to the balance reading of the ethanol-containing flask and stopper, i.e. 6.9046 grams. Since the volume of ethanol in the flask is equal to the volume removed from the graduated cylinder, the volume of ethanol is the graduated cylinder's initial volume minus the graduated cylinder's final volume. In this example, it is 9.84 milliliters minus 1.22 milliliters, which equals 8.62 milliliters. It has been determined that there is 8.62 milliliters of ethanol in the flask and the ethanol weighs 6.9046 grams. Since density is weight divided by volume, the density of ethanol is 6.9046 grams divided by 8.62 milliliters, which equals 0.801 grams per milliliter. pay attention to the number of significant figures. It may be useful to review the significant figures, multiplication and division rule video. The experimental value minus the accepted value will give the absolute error in the measurement. Often, it is more informative to look at the percent error instead of the absolute error. The percent error is obtained by taking the absolute value of the absolute error and dividing by the accepted value and multiplying by 100%. The accepted value for the density of ethanol is 0.79 grams per milliliter. In this example, the percent error is the absolute value of 0.79 grams per milliliter minus 0.801 grams per milliliter divided by 0.79 grams per milliliter multiplied by 100%, which gives us 1%. Pay careful attention to the significant figures, especially during the subtraction step. After the subtraction in the numerator in this example, there is only one significant figure. Therefore, the final answer will be given to only one significant figure. It may be useful to review the significant figures, addition and subtraction, and multiplication and division rule videos. Note that in this example, the percent error was 1%, and thus the experimental result is quite accurate. There are two general types of lab questions. The first is about concepts, and the second involves calculations. The first question is, does temperature affect the density of a liquid? Explain. When answering a question like this, try to think and explain it at the molecular level about what is happening and use this to predict what the results will be. Density is the weight divided by the volume. Does the temperature affect the weight of a liquid? No. The number of molecules in a liquid sample stays the same as the liquid is heated or cooled. So the numerator in the density calculation is not dependent on temperature. Does the liquid's volume change with temperature? Think about the molecules in the liquid. The molecules are in constant motion and colliding with each other. As the liquid is heated, do the molecules move faster or slower? If they are moving faster, will the frequency of collisions between neighboring molecules increase or decrease? If the molecules move farther apart from each other, how does that affect the volume of the liquid? Remember, the number of molecules in the liquid stays the same. Then finally, since volume is in the denominator of the density calculation, how would an increase in volume affect the density? This is an example of a calculation type question. The calculations will often be very similar to calculations done in the lab. In this case, the density is to be calculated. Since density is the weight divided by volume, the weight and the volume of the antifreeze must be calculated from the data. The antifreeze's weight is the weight of the antifreeze-filled beaker minus the weight of the beaker. Note that in this case the weight of the beaker was not tared out. The volume of antifreeze is given. The density is calculated by taking the antifreeze's weight and dividing by the antifreeze's volume. Make sure the correct number of significant figures are given in the answer. Check the conclusion writing guide as it will give what is expected in the conclusion. Generally, terms and techniques used in the experiment will have to be defined and described. Also, the obtained results should be summarized. This is the end of the video on how to write your lab report for Experiment 3, Introduction to Weighing and Density Measurements.